Yeah, let us start. So pulley block systems, we started this topic yesterday. Pulley block systems are in general, they are called Atwood's machine. Atwood's machine. Atwood, name of the scientist who studied these systems. Atwood's machine. So pulley is fundamentally a mechanical device which can change the direction of applied force without changing the magnitude. Only direction of the force is changed by the pulley. Okay. And if you are given a pulley block system, 2, 3, 4, any number of blocks connected with strings which run over a pulley, then the acceleration of that system can be determined using this formula. Acceleration is net pulling force by total mass. Net pulling force by total mass. Very important. And you should understand clearly how to write this net pulling force. Net force means, when do you get net force? If two or more forces act on the body at the same time, then the motion of the body will be decided by neither of the two individual forces, but by the resultant or net of the two forces. Net, that is net force. And net we are calling here net pulling force. Pulling means the net force which acts in the direction of the overall motion of the system. Okay. And for a simple Atwood's machine, M1, M2 blocks connected by a string over a pulley, acceleration is m1 minus m2 by m1 plus m2 into g, and the tension in the string is 2m1 m2 by m1 plus m2 into g. Formulas not to be remembered, to be understood. Procedure is to be understood. To calculate acceleration, you apply net pulling force the total mass, and to find tension in the string, you draw the FBD of any body on which the tension is acting, then apply F net equal to ma to that FBD. You will get the tension. Okay. One simple example we did. Now let us see how can questions be asked in different ways on these pulley block systems. Right. See. Find acceleration of each block and the tensions in the strings. Given situation is this. This is the pulley. This is one block. This is another block. And on the other side, we have another block. Okay, right. Now this is 2 kg. This is 4 kg. And this is 4 kg. If you release this system from rest, what happens? What happens? First of all,
Sir, total mass here, M1 we had to take 4 plus 2, sir.
there are 3 bodies, so you'll get M1, M2, M3. See, we have 2 masses on right side and 1 mass on the other left side. Okay. So 4 kg mass, its weight is 4g. 4 kg mass, weight is 4g. 2 kg mass, weight is 2g. And here 4 kg mass, weight is 4g. What happens? Overall, this side will go down and this side will go up. because weight is more on the right side. 4 plus 2, 6g on right side, 4g on left side. So right side blocks will come down, left side block will move up. Okay. Will they move with same acceleration or different accelerations? Same acceleration, because all the strings, unless and otherwise stated in the question, they are massless and inextensible. If the string is not stretching, if the string is not getting extended, then each and every point on the string has to move with same acceleration. So the blocks should also move with same acceleration. A right downward here on right side, and with same acceleration A in upward direction on left side. Okay. What is the acceleration? Acceleration, net pulling force. See, we will use this formula in each and every problem wherever you want to find acceleration of the system. Same formula, net pulling force by total mass. Total mass means total mass, sum of masses of all the bodies in the system. Okay. Now what is the net pulling force? I told you, tug of war. All questions related to pulley block systems are tug of war questions. If you apply the concept of tug of war here, you will understand uh, which force is more, which force is less. And net force is always larger force minus smaller force.
Sir, answer is 10 meter per second.
Now tell me net pulling force first.
Sir, 20, sir.
Net pulling force. Okay.
4G, sir.
Should I write it like this? See, this side of the system is going down. That means this force is larger. This force is larger. How much is this force? 4g plus 6, 2g. 4g plus 2g. Then this side is going up. That means this force is smaller. Minus 2, 4g. Okay. 4g plus 2g on right side minus 4g on left side divided by total mass 4 plus 4 plus 2. 4g gone. So 2g means 20. 20 by 10, which is 2 meter per second square. This is the acceleration. Clear? Then what about tension in the string? Do we have one string or two strings here? Is there only one string in the situation or
One
two?
string, sir.
Two strings are there. This is string number 1. This is string number 2. Okay. And I told you while studying tension, one string, one tension. One string, one tension. That means if I take this string, let us say as string 1, then tension throughout this string will be same. Tension throughout this string will be same. I'll call it T1. I'll call this tension T1. Okay. And tension throughout this string will be same, which will be different from the first string. I'll call this tension as T2. Okay. If this is T2, this is also T2. One string, one tension. As long as suppose you are traveling along the length of a given string and nothing comes in your path, then tension will remain same. If you start traveling from here to here, string is same, but here you are getting 2 kg block, and this is the other string. So here tension will change because this something is coming in the path. Tension will be different. So T1, T2 are the two tensions. We want those values. Okay, how to find tensions? What did I tell you? To find tension, you should draw FBD. First of all, I'll try to find T1, tension T1. Which block should I take? Which block should I take? 4 kg block on right side, because T1 is acting on that only. Otherwise, you can take 2 kg also, but you have one more unknown quantity, T2 acting on 2 kg. 4 kg is easier. 4 kg block on right side. What are the forces acting on this? Its weight 4g is acting down. Tension T1 is acting upward. And what is it? Is it at rest or moving? It is moving. With
Moving, sir.
up or down?
Down, sir.
Down. So direction of acceleration is downward. A. Now apply. What should you apply? Which formula should you apply to a FBD? F net equal to ma, Newton's second law. We are using only this formula. There is no second formula. In all the pulley block systems, the only formula used is F is equal to ma. Almost 70-80% of your laws of motion chapter is based only on this single formula, F equal to ma. Very simple formula, force, mass, acceleration. Only 3 terms. Okay. But based on this formula, F equal to ma, you can get 1000 different types of questions. Not 10 or 100, you can get 1000 different types of questions. Formula is only one, F equal to ma. And that is where your application should come into picture. Remembering formulas, by hearting formulas is not sufficient. You should be able to apply the formula that you are learning to a given situation. That is what you should do here. So you will not get any question like a body of mass 2 kg is moving with acceleration 4 meter per second square, find force acting on the body. All these are silly childish questions. Even a 6th class, 7th class student can do this. Only substitution kind of questions. Okay. We are not here to do such kind of basic fundamental kinds of questions. You should go for the next level of questions which are application oriented, like this. So if I apply F net equal to ma to this free body diagram, what is the net force acting on 4 kg body? What is the net force on 4 kg? Yes. Tug of war. Remember tug of war. Is this 4 kg stationary or moving? Is the 4 kg block stationary or moving?
Moving, sir.
In which direction?
Upwards.
Which 4 kg block is this? Left one or right one? It is this 4 kg block.
Downwards, sir.
If it is moving, that means force must be there on it. Force must be there on it.
Yes, sir.
Which force is responsible, 4G or T1?
Acceleration due to gravity. 4G, sir.
Only 4G. T1 is not doing anything. Can you play tug of war with only one team on one side, no team on the other side?
Yes.
So if the moment
Tension
you
is
see,
also there, but acceleration due to gravity is more than tension, sir.
no, you cannot compare acceleration due to gravity with tension. Acceleration due to gravity is acceleration. Tension is a force. Force and acceleration cannot be compared. Force and force can be compared. Okay, got the point.
Yes.
The thing responsible for 4 kg block to come down is not acceleration due to gravity. It is its weight. Try to understand this point. Bodies do not come down due to acceleration due to gravity. They come down due to gravitational force. Acceleration due to gravity tells us the rate at which the velocity of the body changes when it is coming down. Only force can cause motion in bodies, not acceleration. Acceleration is a product of force. If you don't have force, you cannot get acceleration. Okay. So acceleration due to gravity is not the quantity which is pulling bodies down. It is the weight of the bodies which is pulling it down. Okay. So this 4 kg block. Okay. Tell me tug of war, 4 kg block. We are playing tug of war with 4 kg block. What are the two teams here? What is first team?
Tension, sir.
Tension. This is first team which is trying to pull it upward. What is the second team?
Gravity, sir.
4G.
Gravitational force.
4G. Weight of the body. Weight of the body is the second team which is trying to pull it down. Who is winning? Who is winning? Is tension winning or weight winning?
Weight winning, sir.
How
Wait,
do you say that?
so because acceleration is acting towards down, that's
Because
why
overall
The block is moving downwards, sir.
right. Because overall motion of 4 kg block is downward. That means obviously for this downward force must be more than upward force. That means 4G is greater than T1. Then what will be the net force? What will be the net force?
Sir, F net is equal to 4G minus T1.
4G minus T1, right. 4G minus T1. Larger force minus smaller force. You need not think much here. It's not a complicated situation, very simple thing. Net force always means larger force minus smaller force. You can decide which force is larger by looking at the direction of motion of the body. The direction in which the body is moving, force in that direction should be larger. Then only motion will be possible in that direction. So 4G is more, T1 is less. So net force will be 4G minus T1. Okay, equal to ma. How much is mass? 4 kg. What is acceleration? We have got it here. 2. That means 40 minus T1 is equal to 8. That means T1 is equal to 40 minus 8, which is 32 Newton. T1 tension in that smaller string is 32 Newton. Then we have one more string, T2, tension T2. Tension T2. To find this tension, again, wherever you want tension, you should draw FBD. Only FBD will give you that value of tension by applying F net equal to M. So to find T2, which block should I take? FBD of which block is to be drawn? Left side 4 kg, right side 4 kg, 2 kg. You should take that block on which T2 is acting. Is T2 acting on 4 kg on right side? No. You cannot take this block now. For finding T2, this block is useless. T2 is not acting on that block. You can take this 2 kg or this 4 kg. You can take any one. I will take 4 kg on right side, left side. I will take this block. Okay. FBD of 4 kg on left side. What do you get? What are the forces? Its weight 4G acting downward. Tension T2 acting upward. Acceleration A, up or down? Upward or downward? Is this left side 4 kg block moving upward or downward?
Upward, sir.
Upward. It is moving upward. Now apply F net equal to ma to this. Apply F
T2 minus 4G is equal to MA, sir.
Resultant force, net force is T2 minus 4G. Why not 4G minus T2?
Sir, because T2 is greater than 4G and acceleration is upwards.
Acceleration is upward. This block, 4 kg block, is moving up. That means, simply from common sense, upward force must be greater. Then only it will move upward. T2 is upward, 4G weight is downward. So T2 must be greater than Fg, and net force is larger force minus smaller force. So T2 minus 4G is the net force, equal to Ma, 4 into 2. So T2 minus 40 is equal to 8. That means T2 is equal to 48 Newton. This is acceleration.
Sir, can you scroll up? I have a doubt, sir. Sir, can you scroll up? Yes, sir. Sir, how 20 by 10 came, sir? It is 2 only, no, sir.
What do you have here? Which is 2? In numerator, you have 2.
Yes, sir, I understood, sir. Okay, sir. Yes, sir, 2 into 10.
G is 10. That should be in mind.
Yes, sir.
Now see, the same thing, the same tension T2, it can also be calculated by taking 2 kg block also. We can find tension T2 by taking 2 kg block also. How? I will draw the FBD of 2 kg block. This is 2 kg block. What are the forces acting on it?
T2 and
T2 acting
2G,
upward. T1.
T2,
Okay.
sir.
T2 acting upward. Then T1
2G.
acting downward. 2G acting downward.
Yes, sir.
Acceleration A downward. Now to this, if I apply F net equal to Ma,
T1
what
plus
is the net
2G
force?
minus T2 is equal to Ma.
Correct. We have already got value of T1, 32.
Sir, I have a doubt, sir. Sir, T1 can act in the top direction and bottom direction. Here we are taking in the bottom, no, sir.
Because
away from the block.
Away from the block. Tension always acts away from the body.
Sir, if it acts in both the ways, then why do we only take up away from the block in FBD, sir?
Because tension cannot push blocks, it can only pull blocks.
Okay, sir.
Right? If this is the 2 kg block, this is the string. Tension T1 cannot act on it like this, in this direction. Tension, you cannot push an object by tying a string to it. You can only pull it. So tension always pulls. T1 we have already got 32. So 32 plus 20 minus T2 is equal to 2 into 2. 52 minus T2
4 is equal to
equal
T2.
to 4. That means T2 is equal to 52 minus 4. 48 Newton.
48.
Same thing.
Yes, sir.
Another model. Finalization of system and tension. The situation is this. This is a table or horizontal surface, and we have a pulley like this. A block of mass 4 kg.
Sir, what you wrote, sir? Find acceleration of system, sir.
String is tied to it, running over the pulley, and to the other end of the string, we are connecting another block of mass 2 kg. If the system is released from rest, Find acceleration and tension. First of all, if you release the system from rest, what happens?
Sir, 2 kg fall down.
2 kg falls down. 4 kg?
Sir, it will come till the extent of the pulley, sir.
2 kg is falling down. Okay. Weight of 2 kg, 2g is acting downward, which is pulling it down. Because of which
Sir,
2
I
kg.
have a doubt. Sir, what is system here, sir? I did not understand.
2 blocks, string, pulley is the system.
Okay, sir.
So 2 kg.
Yes, sir.
So 2 kg, weight of 2 kg is pulling it down. So it comes down. A string is tied to it. Tension is developed in the string. This tension will pull 4 kg block. So 4 kg block will move right on the table. 2 kg block will move down. Okay. Now acceleration of the system. Acceleration A equal to net pulling force.
By total mass.
Total mass. Now what is the net pulling force?
Sir, I got 20/6, sir.
Let us see. What is the net pulling force here?
40 minus 20, sir.
Which 40? This weight of 4 kg? 4g.
It's balanced by normal reaction, sir.
Oh. Then pull a net pulling force.
Sir, net pulling force only 2G, sir.
Only
2.
2. Right, correct. Net pulling force is only 2g. Here,
By
the
6.
understand the difference between the earlier questions and this question. Earlier situations, the blocks were hanging. They were not on any surface. So their weight was pulling them down. But here, this 4 kg block, it is on a surface. Its weight is acting on the surface. Surface gives normal reaction. And these two will be balancing each other because 4 kg block is neither moving up nor down. That means force on 4 kg along vertical direction is 0. Net force is 0. Okay. Then which force is responsible for motion of 4 kg block towards right?
2 kg force.
Tension. Tension is pulling 4 kg block, not 2 kg block.
Yes, sir.
Sir, total mass is addition of both of them, sir.
Not the weight of 2 kg block. Weight of 2 kg block is not acting on 4 kg directly. It is acting through string. And tension is developed due to that thing. Okay, so net pulling force is 2g only. 2g divided by total mass is 4 plus 2. So 20/6, 10/3, 3.33 meter per second square is the acceleration of each block. Okay, what about tension in the string? Tension. To find tension, you should draw FBD. Same procedure. Procedure is same. How you apply is the point. Which block should we take? 4 kg or 2 kg? You can take any block. I'll take 4 kg block. It will be easier. On 4 kg block.
Sir, both have the same tension, no, sir?
Tension T is acting towards right. What is the direction of acceleration of 4 kg? Towards right. So if I
Yes,
apply
sir.
F net equal to ma, what is the net force? Only T
Yes, sir.
equal to Mass is 4, acceleration is 3.33. That means T is how much? 12 point or 13 point something?
13.2, sir.
13.2 Newton is the tension. That's all. If you take 2 kg block, if you draw FBD of 2 kg block, what happens? You'll get the same result, but in a different way. That's all. How? See, 2 kg block, forces acting, 2g downward, tension T upward, direction of acceleration downward. So apply F net equal to ma.
2G minus T is equal to MA.
2g minus T equal to ma. 20 minus T is equal to 2 into 3.3. So T is equal to 20 minus this, 20 minus 6.6. Right? You get the same thing? 13.2.
Yes.
Decimal, you can do the subtraction properly, you'll get the same. So whichever block you take, you'll you'll get the same value of tension. Okay. Another situation. This is a incline of angle 30 degree. This is the pulley. This is a block. How much? Say 2 kg. String is connected like this. And on the other side of the string, a block of mass. Okay, I'll take this 2 kg, make this 6 kg. Now, if the system is released from rest, what happens? Which comes down, which block moves in which direction? 2 kg
Sir,
comes down, or
comes
block
to
moves
the incline, sir.
upward direction.
does 2 kg come down or go up? 6 kg
Go up.
slides down or slides up? What happens?
6 kg slides down the incline.
Because 6 kg is more than 2 kg.
Sir, no, sir. Here, normal reaction is not completely balancing gravitational force. So G can be acted downwards.
Direction will be
Sir, downward.
vertically downward,
Sir, down of the incline.
down the incline.
Yes.
See, wherever you see inclines, bodies placed on inclines, the point is 2 kg, weight of 2 kg will be acting like this, 2g, downward, vertically downward. Okay. Weight of 6 kg, 6g, it will also be acting vertically downward. Weight always acts vertically downward, 6g. Okay. But by looking at this 6g, we cannot tell whether 6 kg block moves down the incline or moves up the incline. to tell that you should take components of this 6G, components of a vector, if you remember. How to take components? I will take one component of 6G along the plane, parallel to the plane, parallel to the incline. Another component
Sir, vertically downward the body, sir. Sir, your voice is breaking, sir. We can't hear. Sir?
Yes. Is it clear now? Is it
Yes,
clear?
sir.
Hello. Am I audible? Oh. Right. See, what you do in situation is we resolve it into two components. One component along the incline, another component perpendicular to the incline. And from geometry, if this angle is 30 degree, this angle will be 30 degree. If this is 30 degree, what will be the components? This will be 6G cos 30. And this will be 6G sin 30. Okay. 6G sin 30 means sin 30 is 1 by 2. So 6G by 2. G is 3G. Okay. Block.
Sir, still it's breaking, sir. We can only see that 6G into 1 by 2. Till there only.
Is acting this 6G into 1 by 2 is 3G. Okay. Is the video also being stuck?
Yes, sir.
Yes.
Uh,
Now it is okay, sir.
so 6G sin 30 acting down the incline, which is 6G into 1 by 2, which is 3G. 3G is acting down the incline. And tension in the string. Tension in the string is trying to pull the block up the incline. 3G is trying to pull the block down the incline. And here, same tension, 2G down. Now, acceleration is net pulling force by total mass. What is the net pulling force? What is the net
3G.
pulling force? 3G minus 2G. Now we can say, after you get this value, then you can say that the block will be sliding down. The block will be sliding down the incline because 3G is more than 2G. Okay. So net force is 3G minus 2G divided by total mass. Total mass is 6 plus 2, 8. So it is 3G minus 2G G. G means 10. 10 by 8 or 5 by 4 meter per second square. Is the acceleration of the system. 5 by 4 meter per second square. Okay. What about tension? Tension in the string. You should draw everybody. Which block? 2 kg block is easier. 2 kg block is easier to analyze. tension T acting upward, weight 2g acting downward, acceleration A of 2 kg is upward. The 6 kg is sliding down the incline. So 2 kg will move vertically upward. Okay. Apply F net equal to ma. Net force is T minus 2g equal to ma. 2 into
T minus 2 is equal to 2 into 5 by 4.
T minus 20 is equal to 10 by 4. That means T is equal to 20 plus 10 by 4. 10 by 4 is 2.5. So 22.5 Newton is the tension. Is this clear?
Yes, sir.
Is it clear?
Yes, sir.
Are you getting my voice?
Yes, sir.
Okay. Right. We'll continue this next type of questions in our next class. Okay. Right. See you and good night.
Thank you, sir. Bye, sir. Good night, sir.